Before we get started, I want to quickly thank the Dean's Office and the College of Arts and Sciences for sponsoring this event. And I want to specifically thank Chris Brooks and Lisa Lawson in the Dean's Office and Rosa Maria in Computer Science for their invaluable help making this event possible. And I also want to thank Sean Wong, one of the Bay Area Database meetup organizers. And I want to thank some of our students as well. We saw our computer science students helping out, checking in everybody at the doors. And I also want to thank Andy Davies, a design major, and the manager of the On-Campus Graphics Center for our promotional images and poster designs, which you can see in the back and around the building. And before we get started with the speaker, I do want to ask that you save your questions for the question and answer session at the end of the talk. So finally, let me thank and introduce our fantastic speaker for tonight. Dan Hubbard is the CTO for OpenDNS. OpenDNS, if you're not familiar with them, offers a cloud-delivered network security service and sees about 10% of the world's internet requests. Dan has been a pioneering force in internet security for more than 20 years. His expertise spans reputation systems to large-scale data mining of the internet and advanced classification systems. He will be talking to us today about security attack discovery through data visualization. So without further delay, let's welcome Dan.
Started when I was like 2. Thank you very much for inviting me, this is certainly a nice university. Glad to be here. First, just a little bit of a backstory of how OpenDNS got into security visualization. I started with the company a little over 3.5 years ago, and when I first started, who's familiar with OpenDNS for stuff? You use us at home or point your IPs at us or something. When I first started, one of the things that attracted me to moving to the company was that they had this massive amount of data, and this 2% that Sophie talked about equates to about 75 billion requests every single day across 160 or 65 million users across the planet. And these are users in very diverse populations. It's universities, it's ISPs, it's people at home, it's people trying to subvert government filtering, it's corporations, it's Fortune 5 companies, so it's a great kind of sample set. And at the time, OpenDNS really was just had these feeds of data that were coming from other third parties to create their security, protect their customers. And there was this kind of great petri dish of data that was not being used and being accessed. So we started hiring a bunch of data scientists and security people to start looking at the data and culling it and building classifiers around it. Two of them are here. Dia and Thomas are both here, and if you have any questions that I can't answer, which is probably a few, they certainly can answer them. But that was awesome, and we started seeing this was kind of early on, when data science was being applied to security, and still very early, as you'll see when I talk about it. But one of the challenges we had was when we tried to sell this idea, and security is full of a lot of BS, a lot of fun, a lot of, we are the best, and no one is better than our solution, blah, blah, blah. And it's really hard to qualify how good you are. And so what we would do is we would get like one of the researchers or me or someone else to talk to the security buyer, and we'd like put math on the screen and go, this is our algorithm, this is how awesome we are. And they'd be like, what the hell does that mean? Well, how much do you stop? So fast forward a little bit more, we created a product which allowed them, basically like a Google for security, to type in domains, IPs, autonomous system numbers, and networks, and we would return back the data that we knew about that, where it was, how long it's been around, what the likelihood of it being bad is, and what kind of these algorithms and the output was. And that was super powerful because people saw that kind of textual representation of that, not the math. But still, it was hard to consume. So then from there, we started thinking, well, how can we make it easier for people to consume the data? And then we started looking at visualization. We hired a gentleman called Thibaut. His name's Thibaut. I think he presented here a while back to the students. And we created a visualization engine around it, which now started off as a way to present how we know a lot about the internet and a lot of kind of pretty pictures, but now has turned into a way that researchers can explore data and find and discover stuff. So that's the short backstory. So I call this kind of exploration data with visualization, obviously for security, but also it's kind of, to me, it's all about kind of security getting back its mojo. And the security industry, I mean, did anyone go to that RSA conference last week? No, last week was the biggest security conference in the world in San Francisco at Moscone. And security is kind of in this weird place where it's super hot. It's in the news everywhere. Like you can't open up the newspaper without hearing something kind of drastic and catastrophic that's happening. But with that, it's attracting all kinds of people into the space that are making kind of outrageous claims that sometimes are more fiction than reality. And a lot of it is just doing the same old thing a little bit differently and not really solving the problem. So, you know, security's kind of lost its mojo and technology mojo over time. So that's why I kind of like the getting your mojo back. So if you think about, you know, security people kind of over time have got this long history and legacy of being very curious people. You know, a lot of security people like to break things. They're kind of known. If you talk to a lot of people that have been in security for a while or kind of interested in security, sometimes they came from a hacker background where like maybe they broke the DRM in something on their phone or on their PC at home, or they pulled apart something, but they like to break stuff. That's kind of one of the general themes. And breaking stuff is another theme. You know, maybe not completely illegal, but you know, on the boundary of kind of okay-ness. And they also like to explore. They're security people by definition not like to break stuff, but they like to kind of push the boundaries of what other things they can find. And with that comes discovery and kind of inventing and finding new things. And another kind of property, obviously, of security, if you're in the security industry, is all about defending. You know, there's not a lot of offense in the security world. Some of that is starting to happen now, but typically security people are all about breaking things, finding things, discovering new things, and then really with the goal of defending people, whether they're at home, at work, or you know, on their phone, or you know, sitting in a coffee shop. And you know, one thing I like to say is that you know, security people are really curious explorers. They're always trying to explore new things. They really like. There's a reason why a lot of security people get this kind of impression that you know, they're in a dark room working on things for hours and hours and hours, and then finally they pop their head up. I found it. I did it. You know, that's kind of part of the hacker culture, and a lot of it is just being curious and exploring new things. And it turns out over the years that this has been great. That the whole idea and the mantra of breaking and building and defending and exploring things has made for good defenders over the years. And this has been going on really since the mid to early 80s. The antivirus industry and firewalls and all this stuff really has, you know, started in like 82 and then started exploding kind of in the late 80s, 90s, and of course to where it is today, where we're talking about, you know, multi-billion-dollar industry. But it really started in the mid-80s, so it's been around for a while. And that's, you know, 30 plus years. Probably longer than a lot of you know, have been around on this planet. And, you know, over these years, we've really been defending through kind of gaining knowledge. And in antivirus world, this is all about collecting data. This is called sample collection. So it's about getting a piece of code, a binary, a website, an email, a spam. I'm exploring it. In many cases, it's reverse engineering. This is taking something, pulling it apart, whether it's, you know, deobfuscating it, figuring out how to unpack it, using tools like IDA-Pro and OllyDebug, and breaking it down to assembler language to understand what it really does, and then creating these vaccines or these updates. That's kind of this circle of what happens. Gather a sample, reverse it, create a vaccine, update it, and everyone's protected. And as the problem scaled over time, more and more people got into this. And it became, you know, kind of a niche thing to do. Like, you know, a lot of people weren't like, I want to be a reverse engineer. But the industry got bigger and bigger. And so more people got hired, more people got trained, and more people kind of entered into the field of reverse engineering or security. And more people, more and more and more. And eventually, companies thought, wow, you know, like any, you know, smart company, why don't we build these literal factories of people that can do this, and we'll train them to do it. And a lot of the antivirus companies actually literally built factories where they put people in the Philippines and India, where literally they were trained on to do one thing, do it really well, get a sample, grab that sample, reverse it, write a signature, and away you go. And that worked fairly well for a while. But then there became a point in time, in, actually a little while ago, where it became harder and harder to hire people, and it became harder and harder actually to gather the samples and to pull them apart and defend. And over time, we had to automate. So we started automating these things. They did things like automatic hashes, automatic fingerprints, behavior analysis, sandboxing. Signatures came out, heuristics and anomalies. These were all things that helped scale the human factories that were behind these reverse engineering firms. But it still didn't scale. And what essentially happened was that along the way, instead of people breaking things, building them, and really becoming curious, they really became these machines of just outputting stuff. And they really kind of lost the swagger around it because they were all, like literally people were compensated on how many signatures they could create, how many things they could do. And that's all they were focused on. They didn't have the time to do other things besides that and kind of push the boundaries of security. And with that, what happened was the efficacy of security started coming down really fast. And there was a time, literally 5-6 years ago, where security companies could realistically say, we have like 98% detection rates. And now if they said that, they would be laughed out of the room. It's like 60%, 50%, sometimes even less than that, where literally if you get a new virus or a new piece of malware, the likelihood of it being caught by the incumbent antivirus vendor is like 1 out of 2. So that is largely because of this kind of model that's been built over time. And at the same time, other industries really started understanding the value of data and what to do with data. And they really started building kind of technologies outside of security without the heritage of technologies and, most importantly, business models. If you think of security today or yesterday, it was really all about selling you updates to these signatures. And if you it's kind of like the light bulb that lasts forever. Well, you're only going to sell one light bulb. It better be really expensive. You're going to break that business model. So they had all kinds of business problems around evolving, and there was obviously technology problems that made them not want to kind of exit that technology because it was bringing in lots of revenue and move to something else. And other technologies didn't have this. This is kind of your standard innovator dilemma. So technologies really started then also embracing kind of the value of large-scale compute. And large-scale compute, whether it be Amazon or GoGrid or your own bank of computers, is starting to be used more and more. And really, this is kind of the beginning of the information age, in the late 90s and in early 2000. And fast forward to mid-2000, now, all of you have got this massive thirst for data. And just in your daily life now, everything is driven by this data. And the data is really skyrocketing. Everything is whether it's your car, where you go, your phone, what you eat, etc. It's mostly driven off of some type of data and large-scale compute system in the background. And the big data movement started. And big data really gives us the ability to absorb this massive amount of data and make meaningful results from it. And security, like a lot of other technologies, is talking about big data, and sometimes when they talk about it, doesn't necessarily mean they're doing something meaningful. So beware if someone says we're big data, they may just mean they're like faster reporting or something. They're really not doing something meaningful. So look under a level below to make sure it's meaningful. And big data really is helping solve pretty dramatic problems. You talk about creating cures for diseases, mapping critical genomes, predicting natural disasters. We hosted a really cool a meetup hackathon earlier this year where people could come and do machine learning, and they had these problems around things they would solve. One of them was like, I think the one that won was like human trafficking, and they looked at all the data of human trafficking, these Craigslist data and all this other stuff, and they kind of outputted how they could actually use data mining to understand how human trafficking worked. So that's really cool. That's awesome. And we live in this very different world now since the 80s. If you think about it, companies like Symantec and McAfee and even some of the firewall vendors were around before Google, Facebook, Amazon, and Twitter. These weren't even companies at that time. So during this, last 10 years, the security companies really have made kind of these very minor incremental attempts at a better mousetrap. So they haven't really made this big leap forward and really changed the way they do stuff. This is things like whitelisting. Whitelisting is the notion of everything is bad unless it's in the list that's good, and then everything gets stopped. And Windows attempted this. That was that thing that came up on your computer saying, are you sure you want to run this? Are you sure you want to run this? And everyone said, yeah. And it didn't work. There was host-based intrusion prevention, containerization, and a number of different technologies that have come out. They're sometimes called next generation this. They usually have the word threat next to it, cyber cloud, sky threat, something. There's a lot of buzzwords out there. And the bottom line really is that not only has the security industry kind of failed in keeping up with the bad people, and that's what people talk about the most, how do we keep up with the bad folks out there, but I think most importantly is the security industry actually has lost pace with technology. And technology moves at a way faster rate than the threat landscape. The threat landscape looks at the technology trends and then tries to do things like that. But no one in their right mind is going to say the attackers are sophisticated like Google or Facebook or Twitter. It's just not the reality. So the security industry really is not gravitated towards these new technologies that are out there. So it's left us a long time behind, and we've got this massive decrease in efficacy. And so my hypothesis is really about how the security industry and security professionals and people that may be interested in getting into the security space can get back to the roots of really exploring data and using their kind of curious roots and their passion around security. And visualization and big data is a big component of that. So to me, it starts off with embracing big data. And visualization is interesting in small amounts of data, but it's not near as interesting, and the value isn't near, in return, it's not there until you have a large-scale data problem, or you have a continuum of time. And what's also interesting is that security, or visualization in general, is really early. This is a very new, although it's been around in a while, kind of in the grand scheme of things, there's a lot of things we can do better than what is being delivered today. And I think there's an opportunity for security to be at the forefront of that because of the problems we need to solve and some of the technologies that are out there, and kind of this mirroring of security, big data, and visualization together. So how do we do that? Well, first, to start off, you need to have some data to explore. And it's really hard to do research without some type of data source of some sort. And more equals better. As I said, it's we're really fortunate. We have a lot of data. We literally have petabytes of data that come into our system. Diversity is really key in security. If you're building classifiers that are out going after attackers to protect everybody in the world, but all your data comes from only the U.S. government, well, you're only going to have good data for the U.S. government. You're not going to be able to protect other people. So diversity is really critical. And one thing that I find is that companies, people quite often underestimate the ability to query the data. A lot of people are like, I want a ton of data, but they don't know how to query it. So we actually have multiple teams in the company. We have a research team. We have a team that is looking at kind of the science of security. And then there's a team that their only goal is to get this massive amount of data and make it queryable. And of those three, you can ask Dia and Thomas, the one around query is the hardest, because it's so much data coming in a massive amount. And of course, all the researchers want all the data all the time in every format in 2 seconds. But that's really hard to do, so don't underestimate that. And also, data silos are also very important. Data silos are really a crux of a lot of security companies now. And companies in general have a lot of silos of data. And that creates problems when you're building classifiers, because your classifiers, even within your company, are only going to be as good as that one silo. And it's depressing to me sometimes. In the 90s, a lot of the big security companies spent all their money buying other security companies, and they didn't integrate the data. They just integrated the companies, and they put like lipstick on the UI, and they kind of sold one product with one kind of UI that looked the same. But at the back end, all this stuff wasn't together. And they didn't get the net effect of the efficacy of all this because it wasn't integrated. APIs are really critical to the data. So why visualization? To me, it's pretty simple. This is actually our billboard outside of Moscone, and this is one real easy way to explain it. We say we don't just see the dots, we connect them. And the first one really is, security, there's a lot of pattern matching and pattern recognition. And that's about connecting dots and understanding how all these dots are associated and graphed and connected together. There's this thing in security that was introduced by MITRE a few years ago called the cyber kill chain. And the cyber kill chain is kind of all the phases of what the attackers do. And one way I think about it is, and these are kind of the 7 stages on the bottom. There's something called pre-compromise, there's the compromise stage, and then there's the post-compromise, and there's like reconnaissance and all these kind of sub-stages along there. But the way I think about it in kind of visualization and data standpoints is there's things we know. So there's a lot of powerful classifiers and things that we know. Like we may know this domain is bad because of the history, where it's hosted, what the attacker did in the past, the reputation, etc. But that's not near as powerful as the things we can infer based off of the graph and the relationships and the connectivity of all of the data. And inferences of guilt are really powerful because it takes one thing and it explodes it into a much bigger net of things that you can go after. And if you think of it kind of like in maybe, physical meat space terms, if you know one house is bad in a neighborhood, maybe you could detect the other bad houses or the other bad actors or the other bad places in that neighborhood by inferring maybe how those relationships of those people, what they do, who goes in and out of the houses, how many times the police goes there, etc., etc. And then what's becoming more important is, so pre-compromise is obviously when you want to stop stuff, but nowadays it's becoming equally as important as what do you do once you're infected, and that is post-compromise. And 5 years ago, no security company would say, listen guys, lots of stuff's going to get in, you know what, then you got to fix it. Well now, it's not that uncommon, and quite often we say, hey, things are going to get in your network. It's just not realistic that everything is going to get stopped. Maybe it's an insider, maybe someone brings in a USB, maybe it's a 0-day we've never seen before. So now it's about what do you do once it's inside the network? And that's kind of the post-compromise. And what's critical in the post-compromise is really learning about the attack. So even in kind of pre-compromise, we may not know why we're blocking something, but then we can infer that we know that the connection is bad in some way, and then over time we can learn that, hey, not only is this bad, but it's also this actor in Russia that's doing a bot network that is stealing credentials from your company. So learning and pulling all these things together becomes really important. But the challenge with that we face without visualization is you get these massive streams of data that are very hard to represent to show the relationships. So this is literally a screenshot of one of our products that is called Investigate, that you type in a domain and we tell you all the other domains that are associated with that domain that are also likely to be bad. So these are inferences of data. And the way we display it is a big JSON blob through the API, or this is the web page. So what you get is a bunch of text with all kinds of names there. So when you look at that, you're like, okay, well, there's a lot of domains that are bad, but you don't know really much more from that picture. All it is just a bunch of stuff. Then you gotta start drilling into the data and figuring out what's going on. Versus this, which is a set of inferences based off of the data that is taken via that JSON information, but visualized. So with this, now you can see, okay, wait, now all these domains are definitely connected in some way. That's the first thing, the human eye recognizes. You can see there's a lot of things that are connected in these clusters. Turns out those are hundreds of thousands of infected computers that are going to, thousands of domains that are going to 12 networks that are in turn going to autonomous system numbers that are essentially controlling the network. And what this works out to be is one big bot network. And this is the connectivity and the graph of this bot network all in one picture. So immediately, without really, if you didn't know anything about security, you would know that these things are connected, and if they were labeled or you moused over them in some way, you could see how they're connected in some way. So pictures are very valuable in looking at representations of data in a more meaningful way than just the text. So let's pivot into kind of visualization today and what the state is really of visualization for the most part. And there's been a bunch of progress around two-dimensional visualization in security. Some good examples, these are all from a tool that we have, an open source project called Open Graffiti, which is at opengraffiti.com. All the code's there, it's all open source, OpenGL, awesome tool. And this is kind of the connection of this attack called Red October, which was kind of an infamous attack almost a year and a half ago of these Russians, which were attacking kind of critical infrastructure and stealing data. And this was somewhat interesting because actually no one knew about it, and then Kaspersky released information about it. One of the things they released was, this has been around for like 5 years, and we didn't even know this was happening. So this is one way that we represented the data in 2D. This was a very interesting attack that these characters in Syria, the Syrian Electronic Army is a kind of an alleged group that is state-sponsored by the Syrians. They took over the domain, the registrar and the domains for Twitter, Huffington Post, and the New York Times. And it may be hard from here to see in black and the colors, but essentially what happened was all of these, this was a bad place on the internet, and this is Huffington Post, Twitter, and New York Times. And when they changed, all of them were pointed for their name servers over to this bad location on the internet. And this was a known bad spot that was hosting a bunch of bad, weird things like illegal purses and Viagra, kind of spammy stuff. But the Syrian Electronic Army used the same infrastructure, so when they pointed all the traffic in the world, it started going over here. And if you could see the picture, you would notice, just with the human eye, two unusual things. One is that New York Times, Twitter, and Huffington Post are not related. They're different companies. They don't share the same infrastructure, they're not on the same web space, they don't have the same networks. They became connected. Not only that, they were connected to a bad location on the internet. So this picture was a great way to kind of visualize that. The kind of funny part about this story was that everybody on the planet went to the Syrian Electronic Army, but do you really think that they could handle the load of all of Twitter and Huffington Post? So their infrastructure blew up in 5 seconds. This is a drawing of a kit called Moneypak and the relationship of all of the infected sites and all their associated, so they use infections to infect all these sites, and they have this kind of infrastructure that's built up that allows them to manage that infrastructure. It's a newer version of that called Moneypak 2. You can just see these clusters of data, and you can see an outlier over there of machines and other hosts. And this is a great one. This is something called Kelios. This is kind of the IPs of infected clients going to the proxies that's going to the command and control. So the cone shape is really powerful in looking at relationships. And lastly, and I've got a kind of an animated version of this later, this is a really cool one. What we did is we took a customer's traffic of all their infected machines, and we said, you know what, you've got all this data, and why don't we graph all that data together and show you a picture of it? And they didn't look at, instead of looking at everything as a different attack going against their network, they could see clusters of the same data, the same infrastructure that the attackers were doing to see and to apply attribution against it. So instead of looking at like 1,200 different attacks, they go, actually, there's probably only like 4 or 5 attackers that are doing 1,200 different things against us. And this is a great one. This is clusters of algorithmic scores. So we score everything on the internet, and it's really good to know when scores are coming together. So let's say you like a bad domain is like a -92, like -92.1 in one classifier. We want to look for things that cluster together to see perhaps they're related in some way. And this is the last one. This was very similar to the Twitter and Huffington Post one. This is a little more recent. This happened in January. This was a Malaysian Airlines. The Malaysia Airlines domain and all their associated properties were redirected to these group of attackers called the Lizard Squad. Which, I don't know if you've heard of the Lizard Squad, but there. A group of kind of radical, a little more radical than the anonymous group in Lulsec. And they took over the whole property. And this shows the graph and the connection and visualizes how they're connected to that bad infrastructure. And one of the things that's somewhat interesting and what's really powerful about these is sometimes because a lot of our classifiers trigger without a human being involved in the equation, we don't really know that something's being blocked. So in the case of Twitter, Huffington Post, and these big events, what typically can happen is people call us, and email us, and tweet, wow, major problem, you're accidentally blocking this bad property. We're like, oh God, we made a mistake. Then we look into it, we find out that we don't. But through the pictures, we can go, oh, the reason we're blocking is because it's connected to this, which is connected to that, and we can see the whole picture. And then post that and go, this is why it's bad. And instead of this big long explanation with all the text and everything else, we could literally just send a picture out and go, here's why it's bad, or write a blog about it and go, here's the explanation, and show that. And people typically are like, oh, that makes sense. It's connected to that bad network, which is bad. And images are great because they tell, a story. Every kind of picture is awesome because it opens up the ability for not just someone to consume that information, but potentially to read through a story with that picture. But it's typically a very short story, unless it's an incredible piece of art, you're not going to stare at it for very long. You're just going to look at it and come away with something very quick. I kind of consider it more like a magazine than a book. You're not going to sit there and look at this picture for a long time. You're going to digest it, kind of like flipping through a magazine, then you're done. So then security over time has started doing things like sequencing. And you see this more often where they're like, hey, here's how the botnet changed over time. I took this one picture, I rendered it, I took another picture, I rendered it, took another picture, I rendered it, and there's like the end thing. And that's how sometimes they show animation, or that's pretty often how people show time. They just show multiple pictures. And this one is actually a little more effective, but I find it actually equally annoying as effective because it's just, in this day and age, really, I expect more than like the flip book, from 50 years ago. I want to see things moving. I want YouTube. I don't want a couple pictures that are happening there. And it really limits the way to explore the data. Through these pictures, you're not exploring anything. You're just looking at information and consuming it in some way. So you're really limited in what you can explore in some way. You're not interacting with the data. So then there's been a bunch of tools which allow you to add context. This is the most popular one out there. This is a tool called Maltego. If you're doing visualization and security, I recommend this tool. It's really good. But it's still flat. It's 2 dimensions. It allows you basically to take one image and then do what they call a transform. So you take that image, you run a bunch of data against it again, and it transforms into the new image. But it does it not just in a picture, it does it in a real-time mode. So you look at it, and then you see the data transform right in front of you. And that's pretty good, pretty interesting. And it's a lot better than flat images, and it helps tell this more complete story, but you still can't really explore the data to the degree that you should. So, 2 dimensions really limits the representation and the exploration of the data. And so the way to meaningfully do that, and the way to be able to interact and explore the data, because, as I said, we really want to start exploring things, we just don't want to consume it. We want to find other things and discover new things. We need to be able to figure out how to explore it. And it turns out 3D models and interactive visualization is really good at this. And it's come a long way since, even 2 years ago, where you had to have like these, supercomputer banks of things to render these big things and look at them and attempt to interact with them. Now, everyone's got pretty good graphic processors in their laptops. D3 is very powerful within the browser. OpenGL allows you to do really cool things. So you can build very big interactive models now. So it's come a long way, but it's going to get a lot better. And this allows you to pivot through infrastructure, the attack, the attackers, and the data in a real meaningful way. Pivoting is something that security people are really used to doing. Starting with one thing, pivot over here, find that, pivot over here, and go through the data. So let's look at some real examples of this. So this is Open Graffiti, and these are some animations within Open Graffiti. Open Graffiti is a tool which can consume any data. You can create your own data and pull it in. But of course, we use it with our data that we pull off of the logs from everybody in the world that points their DNS at us. So you can see this is that Kelios botnet that I talked about before. And the great thing about this is by playing and looking at the data in different ways, you can start feeling and discovering the data and drilling into the data, and more information becomes apparent than what you thought was originally there. So by being able to change the shapes and the forms of the data in different ways, it's almost like looking at a picture upside down or in 3 dimensions or in a different way. Because in one model, you may see it as one thing, and the other model, you may see something that's totally different. And if you're only creating flat images, that would be pretty tiresome to do. You'd have to create one image, snapshot it, look at it, create another one, snapshot it, take a look at it. But if you're actually interacting with the data, you could literally click on a button and go transform from a cube to a cone to a flat image, and the data will be represented and look differently. And in one way, it may look like there's no connections whatsoever, like in this particular example, and then another way, you may see the connections, and they may pop out to you visually. So this is a great example of that Kelios, where these are all of the computers that are infected. They're going to the proxies. So now we know that they're all connected to these kind of proxies. They're in turn going to this main kind of head of the botnet. So if you're trying to take it down or you're trying to defend against it, what do? You go after the top. You want to chop off that one, then in turn, all the other ones can be chopped down from there. Oops, that's the same one. This is the same botnet, but this is looking at the data over time. And time is something we're just starting to play around with, and time is really critical because time is kind of one of those missing elements in security where you always kind of wonder. Typically we find out, oh, what's happening now? We want to know what happened yesterday and the day before, and maybe even build models that can be built to predict over time what's going to happen based off of history. So with this was looking at the Kelios botnet and how frequently the new domains were coming out for the command and control over time. So you can see it's growing, how it's growing, where it's growing, what the connections are of the growth in a time scale. And we actually have a new version of this that actually shows you at the bottom the date and the time and the hours. And this is really interesting because you can see how big a bot network is created, but you can also see how fast an infection is happening. So you can see, wow, people are getting infected more and more and more over time. This is that same Red October infrastructure. This one is a little bit different. So the Red October one was really interesting because originally Kaspersky, when they announced it, only announced that they knew about 3 or 4 domains that were part of the attack, but they didn't know who was going to the domains, and they didn't know what the whole infrastructure looked like. So this is actually the main domain of the attack, and then some associated domains, and then actually the infected clients are in blue, and then the purple is actually the country of where they're all hosted. So when we do things like this, we actually obfuscate the IPs, so like you can't really read the real IPs because there's a privacy issue there. But there was some very interesting locations where this attack was, because when they first came out, they said, it looks like based off of the binary data that we have, the sample, it looks like they're looking for AutoCAD drawings, and drawings with special passwords, and things with the word confidential in it. But, and it's written in Russian, but they didn't necessarily know the motive. So with this, we can look at the connections, and we can kind of make these associations potentially around the motive. So some of these were certain countries that they were going after, and some of these were actually certain entities that they were going after. And it was somewhat scary. We found hospitals that had this in it. There was a theme of kind of military hospitals around that they were going after data. We found military installations that were infected in here. And by looking at the kind of the who, the where, and then the what, and graphing it together, we got a way better idea than just looking at the flat information or just one piece of the puzzle. This is that customer botnet information and the relationships of this. And this shows you how this is actually watching a user click on Open Graffiti and drill into the traffic. So this shows you how interactive the engine can be. So this is, I think it was about 120,000 different leafs within this graph, and it's happening. This is all happening at high speed. We also have the ability to show that kind of pulsing between the nodes is the amount of traffic and connectivity. So you can immediately look at it and go, wow, there's more connectivity happening over here than over there. But because it's interactive, you can drill in, drill out, move in, zoom, rotate around, go upside down, go in, and really start playing around and interacting with the data in an interesting way. And this one was really cool because when we showed the customer, they immediately understood. They're like, wow, we've been chasing, tens of thousands of events, and we should have just been chasing 5 or 6 attacker groups. And now the visualization is highlighting that. Not only that, it's highlighting which groups and how to go after them in an effective way and increase their kind of defensive posture. And no, I'm not going to say what company that was. This is one of the more prettier ones that we have. This is fairly new. This is an attack called Timba. Timba is a very popular and pretty sophisticated banking Trojan that is designed to steal banking information from people on their computers, obviously. It breaks like European TANs, it breaks chip and pin, it works on mobile devices, it's pretty good. But one of the things that, one of the problems that Timba had was that when somebody's machine got infected, it was hard-coded to go out to one location. And so obviously the bad thing about that is once all the good guys find out about one location, they just start blocking that. So what the Timba authors did was they created what's known as a domain-generated algorithm, which computes a new domain name in the algorithm lives in the code on the computer, and it lives in the cloud. So they have a timer that says if they get blocked, I'll go to another domain, another domain, another domain, and they'll do this in sequence. And the reason why they have to do this kind of computationally, and the reason why we can detect it, is because they run into collisions with names. I mean, if any of you have registered a name, it's pretty hard to do, right? You can't just register, Dan.com. I'd love to have Dan.com, but I think it's already registered. So they create these crazy character domains, X, L, G1, X, K, L, V, whatever, .biz. So they create that, and then it gets computed, and they start connecting out to it. So that's really cool. So we had a way to actually block the name based off of this algorithm that we look at the name to determine whether a computer or a human built that. But we didn't know that one name is connected to another name is connected to another name. So what this does is this is actually the connections of everybody that's connecting to one of those domain-generated algorithms and is being blocked, and then connecting to the next one, the next one, the next one, and it's showing the sequence of all of these domains. It shows the associations of all of those. So if we just know one thing, we can infer based off of all the connections and the likelihood of everybody else connected to those bad locations that they're all related in some way, that they're all actually part of the Timba network. This one just actually shows that the power of open graffiti. This is not bad. I'm sure there's some bad stuff in here. But this is the autonomous system numbers and all of the network IP space in the Ukraine. So we picked the Ukraine because they've got some bad actors in the Ukraine. But by looking at this, you can see it's kind of the dandelion effect, where there's one ISP at the bottom there that is clustering and hosting the vast majority of all of the network and all the network traffic and all of the hosting information there. And we've actually we can create images of the entire internet like this now. What we can't do yet is actually create graphical ways to drill into the data. We're not there yet. That's a huge, huge data set. But in the picture, it's Google, Facebook, big Amazon, it's big clusters of data. But at least with Ukraine and a number of other countries and ASs, we can actually drill and interact and move into the data. So it's really cool. This one is, I think the last one. This is very similar to Timba, but Cryptolocker is, in my mind, actually a lot smarter. Has anyone been affected by Cryptolocker and willing to admit it? I'm sure somebody has. So what Cryptolocker does is, assuming your computer is already infected, or they get on your computer another way, what they do is they What they do is, it runs on your computer, and then immediately, once you're infected, it connects out to another domain, and then it does a private public key handshake, and it gets the private key to encrypt all the data on your disk, on your hard drive. And then it encrypts all of that data, and a message pops up on your screen and goes, hey, bad news, I've encrypted all your data. Your data is no longer accessible. Good news is that you actually can pay me with 2 Bitcoins, or $1,500, and I'll give you all your data back. And they essentially then unlock it with the key. So every single computer has this private public key handshake. So they actually use, real cryptography to do this, which is pretty smart. And a lot of people have been hit by this. This is one of the biggest kind of pieces of malware out there, and a lot of companies have been hit by this. And if you have shares, for example, all your shares get encrypted. So it's pretty bad, and you know, backups always are great until you restore them. So people have lost a lot of data or have actually paid. And these guys actually have a support line. You can phone them up and go, hey, I want support. So it's a full-on business. Apparently it's not legal in Russia, and it's okay to do this. They've got an online forum for help, and yeah, they're really useful. So I don't know if I would recommend giving them any money, but they do actually come through. There's a bunch of these in the past that haven't come through. They just take your credit card and away they go. But these ones actually will give your data back. And they've reportedly made millions of dollars about this. So from our standpoint, this was very similar to Timba, but with this, we actually had the ability to break the handshake of the private key. So you were infected, but actually the encryption wouldn't happen. So we could tell our customers, hey, you've got infected computers in your network, you need to go clean them up, because if for some reason their DNS doesn't come to us, they're going to beacon out, a private key handshake is going to happen, the encryption is going to happen, and you're going to lose all your files. So this shows the representation of the relationships of all the connections going to all those machines. And that's how we kind of constrain and connect all the dots with that particular attack. Since then, they've gotten a little bit smarter. They actually are using Tor now and a few other ways to get around it. So I highly recommend you be careful of Cryptolocker. Not sure Cryptolocker works on Macs though. Does it work on? I think there's a Mac version. You guys know? All right, so run a Mac. So let's talk about some of the things we're working on, and then some other interesting trends in visualization, security visualization. One is, you know, what if the interface wasn't actually the visualization? So incident responders and security people all kind of have this workbench that they live in all the time. And this workbench is typically a web interface or, heaven forbid, a Win32 app that they run. And this is where they start open tickets and drill through data and look at information. But they're always pivoting between all kinds of different workbenches. They may have one for domains, they may have one for their malware, one for this. But visualization has got a great opportunity actually to be the interface that allows them to actually be in that toolbox through the pictures and kind of immerse themselves in that. And through the visualization, you can actually maybe even manipulate the data. Right now, we're not actually manipulating any data within the visualization we look at. We're just trying to find other signals and other stuff. So maybe we could do things like in this Moneypak, maybe you could go on the screen and highlight this one section and go, hey, assign, this is all bad. Based off of this picture, I know this is all bad. And you could create a new algorithm or a new training set or tune an existing thing or even just update a new list. With this one, this is a real obvious one. This is all of the scores. And if there's a bunch of scores, if there's a bunch of domains that we know are bad that are scoring negatively, why wouldn't you want to use the visualization to go, okay, that's great, I know this, assign them all as bad, and maybe say that the score is bad moving forward. And so the immersive part is something that we're thinking about, but we're not doing yet from the researcher standpoint. But it's something that's really interesting to us. And certainly we don't know if it's going to be D3, if it's going to be Open Graffiti plus D3, or how it's going to evolve. But there certainly is a lot of momentum and a lot of power coming even from our customers to say, hey, this visualization is cool, I love this, but I would like to do more with it. Not just interact, but maybe act on the data. So other two areas that the visualization is really good at security that otherwise security is really bad at. The first one is education. And you always hear people saying, education is, without education, security doesn't work. And education and security has been really poor, and there hasn't really been great education out there. And the other one is awareness. And security awareness has gotten a lot better, but I'm not sure it's really helped. It's really just been like, wow, there's more bad security stuff out there. I get more phone calls from like uncles and aunts and in-laws now than I ever have. But so there's more awareness of bad stuff, but I don't know what the net impact is. So we, it's been about a year and a half now, started a project around some of our visualization around just displaying the art of the visualization, because there's some pretty awesome, cool pictures. I love like the posters. It's kind of a poster conference. It's the same idea around that, but in pretty frames and putting them up in the office and in other locations. And the great thing about that is, like a lot of great art and pretty pictures and stuff is, unless you label it, the cool thing is typically people want to know. It kind of opens up that curiosity, like what actually am I looking at? And so it opens up a dialogue potentially, which is an opportunity to educate and or provide awareness about something. And so we've got a bunch of art in our office, and we've hung up the art all around different places. Sometimes we put it inside of our building, sometimes it's in different conference rooms. And we actually did this thing called the art experiment, where we literally took my truck and a generator and a couple laptops and posted the visualization on landmarks within San Francisco. And it was at night, and it was like cool places. That's down by the bridge. That's at the Palace of Fine Arts. That's at the Palace of Fine Arts. This one's actually my favorite. So two, like that couple was kind of having a romantic walk, and we were doing this. And we were like, "What is going on here?" This one, we knew we were successful because we actually got kicked out. This is down in the Embarcadero, the ferry building, and that's at the outside the Giant Stadium. And what was really cool was that this opened up not just the ability for us to publish these pictures, but as we were doing it, a lot of people walked by and, what the hell are you guys doing? We're like, oh, we're actually posting malware and security stuff on these buildings as an art project. Like, well, what do you mean malware? So it opened up kind of this education, this awareness that was really powerful, and it was pretty fun. And now we actually use a lot in our marketing material. That connect the dots thing that you saw is something that we talk about quite often. They're great talking points. This is in our boardroom. These are just pictures of different things that we found. This is in one of our offices downstairs. These are all over the wall. And almost literally every single time someone new into the building comes in, they look at those pictures and immediately ask, I gotta ask you, what are these pictures? That we've actually taken some and framed them. That was the one we framed. It's sitting in one of the conference rooms. And so what's next? We've been experimenting with a bunch of new interfaces and interactive ways to look at the data. It started off with Leap Motion. I don't know if you've used Leap Motion. Leap Motion is a little device that plugs into a laptop and your USB, and it allows you to interact with data through the motion of your hands. It's kind of like a very cheap Xbox. It's got a bunch of sensors in it. It's like, I think it's like $80 or something. And the Leap Motion allows you to interact with Open Graffiti. So you actually can interact with Open Graffiti with Leap Motion now. And I was actually I forgot to bring, I was going to bring a video. We actually did another art thing for just employees where actually they played around with, these were like sales and marketing people that didn't know anything about this. And they were just, with a keyboard and mouse, they wouldn't get it. But with the Leap Motion, they're like, oh, I get it. This is how I drill into the data. This is what that means. So it was really cool. Another one is Oculus Rift. We've really just started with this. We've got a helmet. If you can keep it on long enough to not get sick, it seems all right. It's not great with interacting with the data yet, but certainly there's a lot more opportunity for other technologies like Oculus that allow you to kind of immerse yourself in the information. I don't know if the Microsoft Halo project, Halo, whatever. But lots of new ways without, the kind of constraints of a mouse and a keyboard to kind of get into the data. And these are all interesting things to us to experiment, to play, to kind of move forward with. Also, predictive modeling with visualization. The ability to create things based off of history is really powerful if you can continue modeling them past kind of day zero. So, if your model's accurate, imagine if you could tune and train things based off of what you know, based off of what things will be in the future. And that gets really, really powerful in security because we can predict things now, but we just don't know when. We know that they will happen, but we don't know when. And knowing when is really, really important. So building real predictive, kind of forward, future-thinking models is really powerful, and visualization plays a part in that. So to close up, security needs to get back to the forefront of innovation. This 30 years of kind of, finding a sample, reverse engineering it, and outputting it, needs to change. We need to hire more data scientists. We need to have more people interested in data. We need to kind of unlock their curiosity and their passion for security through visualization and through security and through data mining. That's embracing the big data movement. And as I said, I think there's a huge opportunity to become leaders in security visualization and really leaders in visualization in general, because it's very, very early, and minus some really interesting things, kind of in the genome and kind of medical space. I think security really is second to none from the data aspect and the interesting use cases for it. So I think it's a huge opportunity to do that. So with that, I'll close. We are looking for interns, summer interns, fall interns, part-time interns, full-time researchers. So if anyone is interested, you can talk to Dia or Thomas in the back or me after. Or obviously, you can just find me at Dan and Open DNS. We are on Bluxom Street, San Francisco, right by the ballpark, so we are obviously fairly close. And I would love to take any questions if you have any.
First off, thank you for an excellent presentation.
Thank you.
So you were talking about some of the big, basically the task of getting the data, and you mentioned that probably the biggest challenge was doing the queries. And so what's so challenging about, what are some of the unique challenges of doing the queries on this big data?
Yeah, so I mean, the one that's talked about most is kind of the NoSQL movement. You can't just index this massive amount of data. So you can't just stand up like a MySQL server in Apache and run your favorite SQL command. It just doesn't scale. So it's really, one of the challenges with big data is you don't know, in kind of traditional database design, you know what you're designing the data for. And in this, you don't necessarily know what your structure of the data needs to look like. So it becomes a complex problem. And you also want to graph and connect the data in so many different ways that it becomes really hard to construct the data. So that's where Hadoop and Storm and Kafka and Titan and database, Neo4j and graph databases are coming out and providing the ability to do that. But with that, you need to have the expertise to be able to take that. It's not like you can't just cat pipe through graph and connect this stuff together. Any other questions?
Beautiful talk, by the way. I really enjoyed it. You really embraced 3D quite a lot. And I was wondering if you had exposure to some of the sort of more nuanced views on 3D by, say, Incremental.
By nuanced, I would say negative.
Okay.
No,
different. By nuanced, I mean they talk about different kinds of data.
It's not
trackers versus non.
Yeah. So those particular people know, but I was actually joking with the guys before when I spoke at the IEEE visualization conference on security. At the same time, I was speaking about how great 3D model was, and maybe one of those guys or somebody was talking about how bad 3D is and how 2D is all of it. All I know is from the security aspect, you can't explore the data in 2 dimensions, or it's hard to explore the data. And it takes a lot of time to take one model and flip it around and create a new model. And so that time gap is too long So like creating something, re-rendering it, recreating it, re-rendering it, you lose a lot of time in kind of your exploration path. So with 3D, it allows you to do that, kind of explore the data, look at it in different ways. And I've found that really popular. Like most of the stuff that we've done visually, if you actually look at it 2D versus the 3D models and looking at it in different ways, you would actually come up with maybe even a different answer to the picture than you would. And it would be less accurate in 2Ds than it would in 3D. That's not to say maybe in other areas, for sure. Yep?
With the current corpus of data that you have, what do you feel, if you had access to it or could marry it or join it, would enhance it the most?
Oh yeah, that's a good question. We think about that a lot. So we have a lot of DNS data, of course, but there is a lot of raw IP traffic on the internet that we don't see. So raw IP data. So you think about what we have is, 60 million people around the world, every single time they do anything on the internet, they look up a name, that name comes to us and we convert it to an IP. But what if the attacker creates something that just goes raw to an IP address? We don't get that data. We only get it if there's a lookup. So raw IP data is a big one. We've just recently added a new functionality around whois. So we have whois data now. That's really important. Hash data is really critical. Hashes of binaries and the relationship between binaries and domains and IPs and networks is really critical. Of everything, the most critical one I would say is the ability to assign attribution to an attack based off of their motive or potentially even the person behind it. We don't do that. We don't have that data. So if we have a data set and somebody else, and there's some companies that are starting to do this, some companies know who the actors are behind that, those two together become really powerful. Because with ours, sometimes you look at something, you're like, wow, this looks really, really bad, but then it's like, oh yeah, it's like a 14-year-old in Nebraska, just doing something goofy. But it may be, cyber espionage attack coming from China that's going after your corporate secrets. And sometimes with the data, that doesn't highlight as quick as it could. So like attacker attribution data would probably be the biggest one. That's a really hard one. Is there something that you think of that we may need, or?
No, I was just curious. Like,
yeah.
do you capture user agent strings?
Yeah. So we also have the ability to proxy the traffic. In which case we have the proxy. We have access to the proxy data, user agent strings, content binaries, content and ages, those kind of things. But we've actually got a new experiment where we're starting to crawl and crawling. When you crawl, looking at the data that we're crawling and figuring out the data based off of the crawl returns also. Great. Well, thank you very much for coming. Oh, sorry. Is that a question?
Would you recommend a particular degree to work in this?
Degree? I think Sophie would probably be better. better off to say. I mean, anything in math is super important. A math, an early complex understanding of math, I think, is the basis for sure. And then comp sci, obviously, is good. I don't know of too many, kind of progressive visualization, classes, or is there even full degrees in visualization yet? There certainly is great classes like here that are around it. But one of the great things about this is like there's so many tools that are out there or that are starting to come out that allow you to do this. Like I really think about, like when we hire, one way to, if I could rephrase the question is, how do we decide who to hire, like to build these types of things? And one of the, besides fit in the culture of the company, that's pretty critical to us. One is like just the passion and the appetite for the problem. They got to be excited about solving a security problem. And the problem with big data and visualization is it's very, very broad and it's very, very hot. Right? You can get jobs curing cancer, doing better traffic, routing phone calls, or doing info security. So we like to look for people that have the passion for security, of course. And then it's also about how fast you're willing to learn, because things are changing so fast that I would joke like we don't hire mobile developers with like 10 years of experience because they know how to program on Blackberries. Like it's useless. So yeah, the ability to kind of learn and have that passion are pretty critical, but I think the math piece is a pretty big part of it, along with the passion. And an artistic and creative flair is pretty good too. Just thinking in a different way is pretty good. Security people are pretty good at that.
You mentioned earlier in your thing that one of the approaches with looking at data was algorithmic, so anomaly detection, statistical, and then you have this visualization. Are you marrying those now or in that direction where it's not just looking at sort of graph or relational, but you're actually doing either probabilistic or anomaly or predictive modeling?
Oh yeah.
Within that, and what, maybe you can elaborate on what you're
Yeah. So we do tons of classification just based off of the data. We can look at a domain and tell you if the domain is good or bad just based off the construct of the data. We can look at the connections of clients that are going there and tell you if the next domain was bad before or after. There's all kinds of ways that we can classify the data. But right now, the visualization is only a means to demonstrate and look at the connections, not yet a way to tell us what we should kind of add. And that's where that kind of interactive next piece comes. Great. Thank you very much.
Thank you.